With this video, I'm going to show the functionality of the work that I've done. In particular, I'm going to show the execution of the database backend, which downloads the data from Yahoo Finance and stores it in MongoDB, so on a database in MongoDB. And then I'm going to show the graphical user interface with the interaction for the first app and also for the second app. And yes, to start, I can show that the MongoDB database is empty. So if we refresh it here, we can see that there are only the main basic databases. So there is no database which is storing the data for the stocks. These are just the main part, the config and the local. And later on, as soon as I finish to download the data, and we will see that this database is going to be populated with the stocks data. But let's go ahead and let's download the data with the Python script. So I'm going to execute it now. And I have already activated the Conda environment, which I built to work on this project. And let's start. And in this regard, so this is a simple test. So what I did is that I reduced the number of stocks for the moment, which I'm downloading for this video demonstration. So I selected 100 stocks for the Russell 2000 and 100 stocks for the S&P 500 index. Instead, for the Nasdaq, I kept all the 100 stocks. But given that the database backend goes and downloads the data for all the stocks and avoids to re-download it for stocks which are already stored, already downloaded, in case these are appearing into different indices, we can see that the number of symbols that we're downloading is not equal to 303, meaning that there are like 300 stocks plus the 3 indices, but it's only 282, meaning that we have some shares, some symbols which are common among some of the stock indices. So now I'm gonna put on pause the video recording and I'm gonna resume it as soon as the download has completed. I'm resuming the recording, given that we almost finished to download the data. And there has been also an error in downloading the data for symbol, probably because of issue in the connection. But anyway, so let's continue with what we got. So we finished to download the data with the symbol of the 3 indices, and then we stored it in the database. And we can see that all these records have been added to the database. Now, if we go and check the graphical user interface of the database and we refresh it, we can see that now we have the stocks database with the collection daily, which contains the data for the stocks. So I can show in tabular format. So this is it. So we have, for example, here it's Apple, and the data that I have downloaded goes from January 2022 till now, till August 2023, and we can see that the data that we have is for the so we have the symbol, we have the name of the actual company, because we're going to use it in the graphical user interface of the 2 apps. Then we have the date, the prices, so the open, high, low, close for the day, then the traded volume for the day, and then there is a Boolean. So here we have 3 columns with Booleans, where we stored the information regarding the fact that the symbol is part of or not of each of these indices. So in particular, we can see that for Apple, this is part of the Nasdaq, but not of the other 2. And yes, let's move to the next step, which is about running the first application. and this is a Dash application, so we are gonna look at it in the browser. So we're gonna do Control click with the mouse, and it is gonna open on the browser. So this is as I said, the first app. So it's the one about the equities pair trading, and the dashboard is divided into 3 columns. So there is the first column where we can select the data range, and also the type of model, or better, the estimation technique that we're going to use to estimate the spread model. So the spread for the 2 stocks. In particular, the model is defined as the spread is defined as the second stock, the stock B, minus beta multiplied by the stock A minus alpha. And in particular, beta is going to be the actual hedging, the hedge ratio that we need to use when we trade the 2 stocks. And here in the second column, we can see that there is a there are the 2 parameters that we use to define the entry and the exit for the trading strategy. So given that we use the zeta score, so I compute the zeta score of the spread that is computed previously. So here I compute the zeta score, and then for the entry and the exit of the trading strategy, there are 2 values, which are the zeta score entry, which tells us what is the standard deviation multiplier for the zeta score when we want to enter a trade, and this value is considered in absolute term, but then in the strategy is going to be so we're going to look into the positive and the negative values of the actual zeta score, because this is going to oscillate. And then there is the second parameter, which is the zeta score trade exit, which is the level of the zeta score that gives the signal to exit the trade, which has been previously open as either a short or a long. And in this case as well, the zeta score trade exit is symmetric, so we can consider both like negative and positive values, meaning that if we're going to select 0.5 here, then in the actual trading we will have trade happening, so the closing of the trade happening for a zeta score equal to, which is going to touch the level at 0.5 or minus 0.5, depending on the direction. And in here we have like initialized 2 charts, which are going to be like the one for the equity curve and the other one for the zeta score, but also for the rolling correlation. But let's start. So in here we can select the data range to consider for the backtesting. First of all, like I haven't split it into different periods as it is usually done for researching and developing trading strategies, meaning that usually researchers split into the training phase, then the validation period, where the training period is when the models, the linear regression or the Kalman filter are estimated. Then there is the validation period, which is the period where hyperparameters for a model, in this case for the trading strategy, are going to be optimized. In our case, the hyperparameters for the strategy are the zeta score, entry, and the exit. And then the actual performance of the strategy should be evaluated in the other sample. So computed on the validation period by selecting the best hyperparameters, zeta score, and entry and exit, but then the actual final judgment about the model and the parameters for the trading strategy, it should be like on the auto sample. But as I said, like in this case, I'm using all the data set to do everything. So for computing estimating the models, then for checking the zeta scores, and also the final results in terms of risk and returns. But let's go ahead. So here we can select the period, so the data range. In this case, I'm not going to change anything, so I'm going to keep it as it is. But we can pick like whatever period we want. And then as soon as I go and click on one of these 2 radio buttons, the specific model is going to be estimated. So let's go. Let's start with the linear regression, which is quicker, like faster to be estimated. But then we can check also the Kalman filter. And as we can see here, there is a kind of pop-up which tells that the models are that the model is estimated. So in the background, what happens is that I compute the correlations in between all the different pairs of symbols that I have in the database. And then what I do is that I rank all of them according to the correlation value, and I select only some of those so that we can show the actual results in the dashboard, because otherwise there would be like a lot of pairs. So in this case, I rank by the correlation. And then after I selected these, I go and compute the model. So in this case, the linear regression, and I estimate the half-life for the mean reverting spread. And as soon as this is done, also the trading strategy with the suggested hyperparameters, which are the 1.5, which you can see here for the z-score entry, and the 0 for the z-score exit, are evaluated, and then I compute directly the compounded annual growth rate in percentage, and also the Sharpe ratio, so that we can make a quick evaluation for the different pairs, and also depending on the z-score that we go and select. For example, if I'm gonna change the z-score for the entry, for example, if I go from 1.5 to 2, we will see that the table will change right away, but just like the Sharpe and the compounded annual growth rate, because the correlation and the half-life they have been already computed previously in this part. So if I'm going to move here, we can see that it has changed. So we can see that the Sharpe ratio has moved, and the same thing for the returns, and the same thing if I'm going to move the z-score for the exit. So let's move here. For example, the Sharpe ratio is 1.7. Let's move to here, and we can see that the Sharpe ratio is 1.5. And another thing is that by the way that I designed the trading strategy, so the z-score for the entry must be bigger than the z-score for the exit, and this is specified in here. So in case the user is going to select like a different level for the z-score exit, which is going to go above the entry, we're going to see like a pop-up which is going to happen, a box which is going to happen, like shown up in the interface to tell that there is an error, so there is no computation in that case. As we can see here, we have the alert, so it tells that the selected z-score exit is bigger than the z-score entry, and so it suggests to check and update the value selected. So what we do is that we go back and we select, I don't know, like 0.1, and then the alert goes away, and we can see that the values are recomputed. And same thing if I'm gonna move, let's say, let's try the z-score exit here, and I move the z-score entry below the z-score exit, we're gonna see the same kind of alert. And yes, so let's move back to the standard values, 1.5 and then 0. You can see that now it's fine, so we don't have the alert anymore. And now what we can do is that we have all the different results. We can select the row or pair in this table to actually compute the full risk and return metrics. And we can go ahead and do that. So for example, let's gonna select one which has like decent Sharpe. Let's now go, for example, for the first, because it's on the pair of symbols on Google. So two different entities which are traded on the market. Let's go, for example, for this one, so which is still high in terms of Sharpe and also returns. And yes, here we can see now that the risk return metrics are computed, and we can see in the metrics the compounded annual growth rate, which is in percentage, then the Sharpe ratio, the sortino, the maximum drawdown, but also the volatility in percentage, also the skew and the kurtosis. And here is the chart of the cumulative return in time, and at the bottom we can see the chart where I plot the rolling correlation between the two the two symbols. In particular, this rolling correlation is on 10 days, and then we have the zeta score, which is the actual time series that we use to enter or exit into the trade. So in this case, we have like these levels, the 1.5 and the 0 value, which are defining the entry and the exit. So it's going to be like the 1.5 on the top, but also the 1.5 on the bottom. And yes, that's it. If we want to check another strategy, we can move and select it, and so the chart is going to automatically update, and so on and so forth. We can see a few of those. Then we can maybe decide to change the zeta score exit, maybe make the entry a little bit higher too. And then to refresh the chart, we're going to move the selection of the pair, and we can see that if we increase the zeta score entry, then there are long periods when the strategy is not trading, like for example in here and in here. And as well, if we move to very high values, for example in this case there are no points where on the zeta score that are touching the level 3, so we can see that there will be probably no trades for this one. In fact, we can see here that the Sharpe is 0, compounded undergo rate 0. Let's refresh the chart and we will see this flat line because there is no actual trade happening given this level of the zeta score for the entry. Instead, if we move to 1, we will see that some trade is happening, as we can see here. And yes, okay, let's go now to select the other model, the Kalman. Actually, let's try to move the dates. For example, let's move to, I don't know, February 2022, and then let's select, I don't know, April 2023, so the 30, and then let's go ahead. As we can see here, everything is cleared. And okay, there was a problem with the lack of data. Maybe let's try to expand it back. Because what I do for the data is that I merge, I do an inner merge of all the time series. So in case there are time series, so symbols which stop trading, then there are problems because there is no data which is going to be selected. Let's try again to refresh. Let's start with the OLS, then let's try with the Kalman filter. Okay, in this case there are no problems, so meaning that we actually have data for the stocks. And here we see again that we have the correlation and the half-life. In this case, the half-life is computed for the Kalman filter. And then we can move like to this chart, this table. And again, if we move these values, we can see that the Sharpe ratio and the compounded undergo rate are going to change. And actually, given that the Kalman filter is generally speaking a better model with respect to the linear regression, mostly because the beta and the alpha, so the two parameters of the model, of the spread model, are not static like for the linear regression, but they are dynamic, so they change with the data, and we can see that this dynamic way of estimating the parameters is giving better results, in particular in terms of the Sharpe. For the compounded undergo rate probably as well, but I don't remember the number. Instead for the Sharpe, I remember that for these initial values there were not Sharpe ratios as high. So for example, let's select this 5.6, and we can see here the results in terms of the cumulative return and also the zeta score and the rolling correlation as well down below. And yes, that's it for this first application. Now what I do is that I go I go and close and shut down the Dash server so that I can start the second application. So I'm going to press Ctrl+C, and here it's stopped. So if I go here and refresh the page, there is nothing because the Dash server, the local server which is running on this, so on the IP for the local host, so for this machine and this port has been stopped. So now we can go here and start the second application, so up to, and let's see. Again, this is started on the same server IP and address, so this is put on the port on this local machine. So if I'm going to refresh it, we can see the second application. So the second application is on the multivariate index regression, or multiple index regression, better defined. So in here we can select the stock index, the actual stock index, which can be the S&P 500, the Nasdaq 100, and the Russell 2000. And I have to say that we can read the names here, pardon, because in the background I download, apart from the data, so the symbol, I also download the name, and this is useful if you want to select the specific stocks, in particular in this other box in here, which can just select one of the three, because that was the specification of the project. So let's keep, or maybe let's try just to change to the S&P 500. I remember that in the background, in the database, I am storing only around 100. Actually, it is 100 for each of the indices, but in total it's less symbols. So I have like 100 symbols for the S&P 500, and if I click here, we can see that there are like all the symbols with the specific name of the company for these 100. But in case I had included all the 500 symbols, we would have seen like all the 500 symbols. And the good thing of this box is that we can search by name or symbol. So for example, let's go and search for General Electric. We can select it, and we can see straight away that the chart, so the scatter plot is plotted, and in this case, so we have the index, which is the S&P 500, and here the model prediction is nothing more than the actual the Y in the regression model, which has been estimated, and this is compared with the value of the index. And here on the right, we can see all the different results for the ordinary least square regression. In particular, we can see that the variable that we are using as an output is the S&P 500. Here we can see the exogenous variables, in particular by using the symbol. So this is G for General Electric, which is here, and then we can see all the other different values for the metrics. For example, like one of probably of the most important is the R squared, which is almost 0.3, and we can see that the as we add other shares, for example, let's try to add Etsy here, which is selected here. So we can see that straight away the model is going to be re-estimated, and here also the new values, for example, for the coefficient for the Etsy, and here the updated R squared. And we can go and continue ahead by selecting a few stocks, for example, Google. Let's continue, street, and we can see that the model is getting better and better as we increase the number of stocks. As we can see here, the R square is improving, and so let's try to reach 10 stocks, and then we will see that no more than this can be selected. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can select more than this, because this was the object of the project, to allow only the selection of 10 stocks. And here we can see that the scatter plot is much better respect to the initial one, and the R squared is equal to 0.9, almost so 97%. And here we see the values for all the coefficients for all the different symbols. And now if we go and clear this box, we can see that everything disappears, and here we have the kind of alert which suggests us to select at least one stock. But what we do is that I go ahead and test this other feature, which is about automatically selecting 10 stocks or less that are the best given the method to explain the index. So in particular, in this case, I'm using a single approach. I have implemented two, but I am using only one, which is based on regression trees, and to be specific on the XGBoost model. So basically what I do is that I look at the feature importance of all the shares, all the stocks in explaining the S&P 500 or the other, so the specific stock index that has been selected, and then I select the best, so the ones with the highest feature importance in the model, and I give them as an output, and these are going to be added in here, and they are going to be used for estimating the model. So let's go ahead. So here there is an alert which is telling that is giving the information that it is selecting the stocks, so we need to wait a little bit. Okay, here we have the list of all the symbols with the name of the companies. So Equifax, Microsoft, Alphabet, Align, NetApp, News Corp, Regency Capital One, IDEX, and Martin Marietta Materials. And as we can see here, we get the R squared, which is higher respect to the one that we have seen before, which was about 97% by selecting at random the stocks. So it is better. And yes, so let's go ahead and let's try with another index. Let me clear these. Let's move with Russell. As well, we can select the stocks. So let's go, for example, let's select Zip Recruiter, or we can search also as with Recruiter, and we will get it as well. So then which other ones? Enterprises. So these Werner Enterprises, we start by writing Enterprises, and here it goes. The second, and then we can select other ones randomly till we reach 10. And as well, we can see that the scatter plot is updated automatically, and also the values in here, and we get R squared, which is 0.9596. Now let's go and select the best stocks in an automatic way. So I haven't cleared the box, but it should be fine, as it is repopulated by the tool. And actually, the second method that I have implemented to select the features. Okay, so we have the results. The second method that I have implemented to select the features is one which is still like coming from let's say machine learning, but it's statistics. So it goes by the name of the sequential feature selection, which can be forward or backward. And what happens is that in that case, I estimate a model by adding one feature at a time, so one symbol at a time. In particular, as a model, I have used the linear regression because it's easier and quicker like to estimate. And so I add like one symbol per time, and it checks the results. And as soon as it gets like it gets like better and better values, then it selects in this grid fashion like the set of the best 10 features. But it can go also backward, so meaning that it can start like with all the symbols or features for the model, which in this case is 100, because as I said, for each index there are 100 symbols right now in the database. So it goes and selects these ones and removes one per time, and it does the computation in terms of the performance until it reaches the optimal kind of greedy set of 10 symbols or features. And as we can see, like with these, in the actual application, I'm using only the XGBoost because the other approach is more time consuming, but I left the code in the application in case we want to enable it in other cases. So as we can see here, the R squared is better respect to the one that we have seen before, because this is 96%. And yeah, as for completeness, we can go and do the same thing for the NASDAQ. So we select the, for example, the Autodesk by writing desk. So we get like both of them. Let's write also the other one. Get the other one, the trade desk, and then let's select other random ones, and we can still see that the scatter plot is getting better. And here we have like 10 stocks, 10 symbols, and the scatter plot, and then the results, particularly the R squared. As well, we can run the select the best stocks with this automatic approach, and that's it. And here we can see that the R squared has improved, and also the scatter plot looks better in terms of having a smaller standard deviation for the points that we're plotting. And yes, that's it. So now I can stop the application to conclude. Okay, and thanks for watching.